this video, we'll flash our Jetson Nano development kit with the latest L4T build available. There are multiple options to flash the build. We can either download the SD card image and use Etcher to write the image to SD card and then plug it into Jetson Nano. Then there is the NVIDIA SDK manager, which makes it easy to download all the components required and flash L4T software. We'll be following this approach, but not completely, because there is an issue wherein after flashing, the root file system is around 14 GB only, irrespective of your SD card size. So you might be having an SD card of size around 32 GB or 64 GB or 128 GB, but the software wouldn't be using the partition would be still limited to 14 GB. So I'll show you how to overcome that limitation for now, but I guess NVIDIA has plans to fix this in the upcoming releases. We'll go to the docs.nvidia.com and we'll select L4T, and then we reach the docs for L4T. Here, if you go down to flashing and booting the device, and you can go through the whole documentation. It's pretty well documented. And if you go to the flash script usage, so you'll see how to use the flash script, and you see an argument over here which is hyphen capital S and the size. It says the size of the rootf is in bytes, valid only for internal root dev. So this command, this argument would help us change the rootf size to something what we desire. We can go down and yes, so there is a section here which says increasing internal memory partition for root file system, and it suggests to use the hyphen S and the size in bytes. So we'll be using this. Let us go and download the SDK manager. Once you go to the developer nvidia.com, then from that site you can go to downloads and then Jetson. So it will take you to the Jetson download center and you'll see the SDK manager. You can download the SDK manager, install it onto your Ubuntu system. Okay, so this is the issue which I was talking about. Fine, so I have already installed the SDK manager. I'll just launch it. Log in with your NVIDIA developer account. Now once you log into the SDK manager, you can select the product category, which is Jetson. If you want to perform some host machine setups, then you can check this. If not required, then you can uncheck it as well. From the target hardware, you have to select the Jetson Nano developer kit, and I guess a Jetpack 4.4 DP is the developer preview version of Jetpack 4.4. You can go ahead with this. This is the additional SDK deep stream. We don't require it right now, so we'll go ahead and click continue. So I have already downloaded all the required components, but I'll just show you how to go ahead with the flashing part. So this is the Jetson OS. You will have to accept the terms and conditions here. You can specify your download folder and the image folder. There would be a dialog which would pop up while flashing, which would ask you to put the device into force recovery mode, and that is a time when we will apply those changes related to the rootf size. So let's go ahead and click continue. In the meanwhile, with with the device, what you need to do is you will have to insert the SD card here. There's a slot, just behind this heatsink, and you have to insert the SD card there. So once you insert the SD card to the Nano, short both the pins in case you want to power the device with DC jack and not from the USB, and which is important. Also, if you see these pins, so these are the pins for reset. Then there is force recovery on. So force recovery is the pin that we have to short to bring to put the device into force recovery mode, which will help us to flash the device. So what I'm going to do is I'm going to place the jumper on the force recovery pins, inserted the SD card. I'll put the USB cable for now, and the power adapter. And then what you can do is you can remove this jumper. Now let's first check if the device is in force recovery mode. So we can do it with the LS USB utility. Now if you see something like this 7F21, then this means that the device is in force recovery mode. Now either we can proceed with this particular flashing. So the dialog is asking for the username and the password of my already configured device, and this is the time when we can skip this particular setup. We'll skip this, close the SDK manager. We can go to the location wherein image was created. I guess in my case it would be here. We have this one as well for devkit. So this is where you'll see the folder Linux for Tegra. So go to this folder and you will find all the L4T required components here. Now you'll see the flash.sh file which you will be using to flash. Now what you need to do is in terminal go to this particular location, alright, and check the let's go back to the documentation wherein we had seen the flash command. So it says this would be the flash command. The board name would be, yeah, so the board name would be, I think they had it mentioned here. Okay, so in the quick start guide you will see the board name. So these are the board names for different platforms that they have. We are using Jetson Nano, and so the board name would be Jetson Nano QSPI-SD, flashes both QSPI NOR and memory and SD cards. We'll be using this. So let's start with that flashing command. Alright, so this is our flash command. Okay, so I see that the flashing has started. Fine, the flashing is done. Use minicom, and when you connect the device with the USB cable, you'll have this ACM0. So let us launch this with sudo. So this is the setup part. Okay, I agree to the license. Okay, English, yes. Country, in India. Yes. Okay, finally we have the login screen. Let me try once more. I think there was some garbage prints due to which the login was successful. Okay, we have logged in. Now this is we are inside the Jetson Nano. Cool. So you can access Nano with this the dev/acm0 interface, or if you do an ifconfig, you'll see something like L4T br0, which has an IP address 168.55.1. Let me just split my terminal, and so the second terminal is actually pointing is my system, the host machine, and if you see there is another interface which is this one. Sorry, this one. Now this has an IP address 192.168.55.100, and so so we can connect to the Nano device using this particular interface. You can check with ping 192.168.55.1. The ping is successful, and we can do an SSH. Okay, I think this is my previous device that I had. Yes, and yeah, we are in with SSH in the device. So that was the flashing part. In the next video, maybe we'll start with how to make the robot working over Wi-Fi controller app. All right, thank you.